Okay, so as I'm looking at probabilities of compound events, I can use sample space or tree diagrams, as you should have watched in the Khan Academy video. But if I had a problem like this, if you flip 3 fair coins, what is the probability that you will get all 3 heads? There is a mathematical way of solving these. When you have compound effects, if you take the probability of each individual outcome, favorable outcome happening, then you would end up with something like, well, I have a 1 in 2 chance. Sorry, that's an ugly 2. 3 ugly 2s. Okay, I have a 1 in 2 chance of having a heads on the first coin. I have a 1 in 2 chance of it happening on the second coin, and a 1 in 2 chance of it happening on the third coin. Because all 3 of those were independent, each one is still 1 out of 2. But since I'm compounding them, making them dependent on what happened previously, I need all 3 of those to be heads. So the likeliness of this can be discovered instead of drawing a tree sample or a sample space where I list all the possible options by multiplying the probabilities together. So 1/2 times 1/2 times 1/2. And again, if I was going to go ahead and do this, remember numerators times numerators, denominators times denominators. So really 1/2 times 1/2 is 1/4. And then timesing that by the third choice, the third outcome. So 1/2 times 1/4, which still gives me a numerator of 1, but 4 times 2 is 8. So out of all the 8 possible outcomes of flipping a coin 3 times in a row, only one of them is going to involve heads happening on all 3 coins at one time. So the probability is going to be 1/8. You can complete all compound event probability problems like this as long as you know the probability of each event occurring, okay, and you multiply them together. You're going to get the same answer as if you were to use sample space or tree diagrams to write out all of the possibilities.